Alright, we're working through section 3.3 and I'm going to demonstrate to you guys how to solve question number 15 from, James Stewart's Calculus Early Transcendentals 9th edition. So, to start with, we are taking the derivative of this function. The important thing to notice is it is a fraction, and every time you see a fraction, it basically means you're going to need to use the quotient rule. When you see fraction, think quotient. Fraction, quotient, fraction, quotient. It's one thing to sort of memorize. And now we're going to need three derivative formulas. The first is we're going to need the tan x formula to get rid of the tan x on the bottom. We're going to need a derivative of a constant because we have that 2 there, and we're going to need a derivative of x because we have an x on the top. So you can find these derivative rules at the start of the chapters. There's also an appendix in your book, but you should probably memorize these or at least be able to locate them on a formula sheet. So the first one, the derivative of x, is just 1. The derivative of tan x, well, we have negative in front, so we can factor that out, and the derivative of tan x is simply secant squared x, and then you still have your negative left over. The derivative of 2, because it's a constant, is just 0. Alright, so we make our little table and we identify the different pieces. So what's g? What is the top? Well, the top is just x. And then what's the derivative of x? It's 1. And what's on the bottom? 2 minus tan x. And what's the derivative of the bottom? Well, you're going to have 0 replacing the 2, and then of course the derivative of negative tan x is negative secant squared x. Alright, and so now the next question is how do we solve this? So we have to throw it into our quotient formula here. So to start with, what is g prime of x? Well, the derivative of g was just 1. And then what was on the bottom left alone? Well, that was just 2 minus tan squared x. And then for our second term, we're looking for what was g left alone. That was just x. So we write it again, making sure not to forget the negative. And then what was the derivative of the bottom? That was just 0 minus secant squared x. I'm going to drop the 0 because there's no point in writing it again. So we just have negative x and negative secant squared x. And now we're just simplifying. So the first term, if you go 1 multiplied by anything, it doesn't change the value, so we just once again write the 2 minus tan x. For the second term, we have a minus x multiplied by minus secant squared, because there's two negatives, they cancel out. So this just becomes plus x secant squared x. And on the bottom, well, there's no real way to make this simpler, so we just write it again. And that's all you had to do to solve this problem. It wasn't the worst one. The hardest part was probably knowing the derivative rules and knowing that basically tan x is secant squared x when you take the derivative.